Hey everyone, so here is our amplifier circuit. So let's see that how we can solve this circuit and how we can solve it by dividing it into different regions. So let's first divide it into different regions. Let's first divide it into a diode region. So we can see a diode here. Then we can see an amplifier here. Then let's see what it is asking for. It is asking for to find this R, to find this R, to find this RD, that diode resistance, and the ratio with width and length ratio of Q1, Q2, Q3, and Q4. Then it's also asking us to find the input common mode voltage range for this design. So let's see how to get these things. At first, let us find that what is the values of different voltages like source voltage, gate voltage, and drain voltages. So from here, zoom it a little bit. From here, we can see that our VDQ and VG4 are same. And we can also see that VS4 equal to minus 0.9 volt. So here, if we have this VG4, then we will find VD4. And then if we can find VD4, then we have this VDD, and then from here the voltage difference divided by the current ID4 will be my resistance. So let's figure it out. So here we have, let's see that what we have to find this VG4. We have this V overdrive here. So we have V overdrive, and what we need, what else we need? This V threshold, right? So here they also give us this V threshold. So as we have V overdrive and V threshold, so we can say, and also as it is a diode, MOS diode, so we know that MOS diode works in saturation region. So we can say saturation region. So we can use it in later on. Now we directly know that V overdrive equal to VGS minus V threshold. So as VGS minus V threshold, and we also know what is this S is 0.9. So from here we can say that V overdrive 4 equal to VG4 minus VS4 minus V threshold. And here we can say that VG4 equal to V overdrive 4 plus VS4 plus V threshold. That would be basically our V overdrive, that is 0.15 plus our VS, that is minus 0.9, and then that would be our V threshold, that is 0.4. So what we can find here, let's calculate. Here we can find 0.15 plus 0.9 plus zero point 0.4, that is minus 0.35 equal to Vg4 equal to Vd4. So we know that this R equal to our del of V or del of I equal to Vdd minus Vd4 divided by this I. So we can also say that our VDD is 0.9, so plus 0.9 minus of 0.35 divided by 0.1 equal to 12.5. So now it is not ohm, it is kilo ohm, because our the whole thing is volt, and this thing is milliamp. So this is kilo ohm. Now we have this R, so we have solved this. Now we have to solve this RD. So from here we can also see that their VDD is given, their ID is not given. There, if you see the question, so you can see there is a DC voltage given. So it is,
So here you can see that now we need to find this RD. So we can see here that RD, we can find it from VDD minus VD1 or D2 divided by our I, that is the half of zero point 0.4, because of the two sections are symmetrical, totally symmetrical. Our RD is same, V over drive is same. So we can find 4 kilo ohm here. And then we need to find W by L. So from the MOSFET equation, we know that ID equal to half Kn prime W by L and V over drive square. So here we put the saturation equation because all the MOSFETs are in saturation. And here we can find this KL by mu COX, C oxide, and we get this from our equation. So from here we can find W by L equal to 2I mu COX V over W square. So we can find all the W by L of all these MOSFETs individually, and also we can do this like our mu COX and V over I is same for all the MOSFETs. So we can find that W by L is proportional to I. So W by L 4 would be, and then we can find W by L for 1 and 2, that would be our W by L for number 4 divided by ID 4 into ID 1 or 2. So we can just put it here. And our MOSFET will have the threshold voltage. So we see that Across the resistance there is a voltage drop, so we can find VDD minus IDRD is the voltage drop, and then VTH. So we can add these two and we can find the common mode voltage for maximum. And then eventually we can, if we see from the bottom, we can find one MOSFET, then that MOSFET has overdrive, and another MOSFET, that MOSFET has overdrive and Thevenin, uh, and overdrive and threshold, and the VSS. So we can find minus zero point 0.2, and this is the minimum, so we can find minus zero point 0.2, from minus zero point 0.2 to till 0.5 is the voltage range. So if this video helped you, then you can like and subscribe this channel.